talk to her. I should have talked to her about calculus.
Okay, so an integral is the area under a curve. So if we have the line y equals 1 half x plus 4, we take the integral from 2 to 6, find this area. Okay? We can all do that, right?
Yep.
So basically, when we're finding the area under a curve in this situation, okay, between the curve and the x-axis, that's the area under the curve. Okay? So in this one, we would integrate 2 over x from 1 to e squared. Okay? How do we integrate 2 over x?
X to the negative 1, so it would be x to the negative 2.
2 ln of x. Yes, you are correct. Because x to the negative first is the integral, that is ln of x, from e squared to 1. So it's 2 ln of e squared minus 2 ln of 1. What's the natural log of 1?
10.
0. Thank you. Voice of reason. All right. What is the ln of e? It's 1. So the ln of e squared would be 2 because the ln and e cancel. So that would just simply be equal to 4. So this area here under this curve would be 4. Okay, that makes sense. So the other area under this curve is the integral from negative 4 to 2 of x squared plus 2. So when we integrate it, it's 1/3 x cubed plus 2x from 2 to negative 4. It would be nice if our graphing calculators would do this for us.
We've been over this before, does it not?
No, Taylor knows that it does.
So if you go math 9, math 9. Oh, look at that, an integral symbol. So if we integrate, and we type in this one, not this one after we integrate. So if we integrate from negative 4, integral from negative 4 to 2 of x squared plus 2 dx. Was that Hodgin? The door opened because then it closed again. So must be.
Hey, is Pi Day on Tuesday? Like a week from today? Oh my gosh. Time flies.
Yes. Okay, I screwed that one up again because I need to put a negative 4 on the bottom, not a 4.
Wait, so do you put dx? Yeah, I got 36. Okay, this might be a dumb question. But is the lower
Which is
number always
36.
on the bottom? And how do you know the number's on
You
the
go
bottom?
from left to right.
Like
Right to
whatever it says in the question.
Right to left.
Left,
No.
left, negative 4 to right. So this is on the bottom, this is on the top.
Yeah,
I was
so
thinking
the lower
top
number-
Yeah, top to bottom is right to left.
Okay.
Yeah.
Lower number is always on the bottom.
Yes, unless they switch it around on you and then your answer will be the negative of what it would be otherwise.
So like either way, I'm gonna get the answer. It's just the
What
difference.
logical purpose does that serve?
Negative or
I don't know.
positive.
Yeah, but
But then when,
That came
Yeah.
from
Thank you.
I said I'd send it to the talk to you today.
I don't know why, but they have the integral rules that say, well, if we would, this is equal to 36. So the integral from 2 to negative 4 would be negative 36. Yeah, the area is still 36 no matter what.
So it
But
can't be negative.
what?
It can't be negative?
What?
Well, not
The
in this
area.
problem.
Area can't be negative, but if the area occurs underneath the x-axis, then it is negative. Yeah. So, now, is there another way our graphing calculator solves this? Yes, on the graph. So on the graphing calculator, if we graph this out, clear. All right. So if we take this and graph this function x squared plus 2, and we graph it, it looks like this. And if we go second trace, and then there's an integral symbol, which is number 7. If we go from -4 to 2, it finds the area under the curve, which is 36. Okay? Now, this will be important because we're going to get into more complicated problems that we're going to get into more complicated problems that we want to use the graphing calculator to help us out. Now, will they allow you to use a graphing calculator on all these problems on the AP test? No. So you really need to know both ways of doing it, but to kind of help you out doing a few more problems, I show you this. All right. If this region has an area of 18, what's the value of K if K is right here? If this is K. Okay. Well, where does the function start at? Negative what? We should know looking at this equation. You think.
-3.
There you go. That's how. Because what makes 0 here? A -3 will make it 0. All right. Woo. So we go from -3 up to K of x plus 3 to the 1/2 power dx. And that should equal what? 18, because it says the area is 18. Okay? All right. So, how do we integrate this? Well, it becomes the 3/2 power, right? So what goes in front? 2/3. Okay. And from -3 to K equals 18. Are we good with that? Now, because this is 1x, the first derivative of 1x is 1. So this multiplied by 1, so it really didn't matter. But if this was like a 2x, we'd have to multiply this by 1/2 to counteract that. Because when you do the chain rule, you do this times this times the first derivative. Remember? But the first derivative is 1, so we don't have to worry about it. Okay? You got to remember some of those little things from first semester, like chain rule. Okay, so reversing the chain rule. So, how can I solve this? Because this looks really complicated.
You can separate it out and plug in 3 and then
So, how about we multiply both sides of the equation by 3/2? Okay, if we do that, this becomes 9 times 3, which is 27. So x plus 3 to the 3/2 power from k to -3 should equal 27. What else could I do to make this simpler? Separate them out.
What if you took the whatever?
Well, we take each side to the 2/3 power.
That's what I meant.
And then we have just simply x plus 3 from -3 to k equals 27 to the 2/3. The cube root of 27 is 3. 3 squared is 9. So now if we plug them in, k plus 3 minus -3 plus 3 should equal 9. correct? Plug this in, plug that in. Well, negative 3 plus 3 is 0, so that basically cancels. K plus 3 equals 9, so K equals 6.
I was so close.
What?
Someone gets 5 at the beginning.
Oh,
Oh, I did
okay.
guess 5, guys. Dude, there's a couple of them I guessed 7. I got it right.
Okay, this one, if you get this, if you talk me through this, and I'll let you try to talk me through this, and you get it right, then you're really good. Because I got this wrong this morning when I was trying it.
20 extra credit.
What?
20 extra credit.
Sure, I'll give you an extra credit point. 1. Okay,
Okay.
so setting it up, I think everybody should be able to do.
0, or the integral from 0 to k is something equals pi over 3. How do you know that? Because it says right there. Oh, I thought that was a different question. Okay, sorry. I did that for the last one too. So then you take the integral of that.
Which is?
I would have to look it up on my calculator. I don't know. The ln of x squared plus 1.
That's what I tried this morning, and I was totally wrong.
Okay, so then it's just like x to the negative 2.
This is Go Taylor. You erased them from up there. Here.
Yeah, I did erase them from up there.
What is the trig function?
Tangent?
Bruh, I never would have guessed.
This is the inverse tangent of x from 0 to k of equals pi over 3. Very good. There you go. I'll throw you a point of extra credit, Taylor. All right. So the inverse tangent of k minus the inverse tangent of 0 equals pi over 3. What's the inverse tangent at 0? Think of a unit circle. 0. Because 0 over 1 is 0. Okay? Or where tangent is equal to 0 is 0. Okay, so whatever, that's 0. So the inverse tangent of k equals pi over 3. Where is the inverse tangent, or wait, yeah.
Where is inverse tangent equal to pi over 3?
So what is the tangent of pi over 3 basically? What is the tangent of pi over 3? Because the inverse tangent of this crazy thing will be, yeah, pi over 3. So basically what we're saying is the regular tangent, k equals the regular tangent of pi over 3. Because if we take the inverse of the inverse, it's regular tangent again. Oh, quit it. Exact value of k. Yeah, there's square roots involved. So at pi over 3, the x is 1/2, the y is square root of 3 over 2. So it's the square root of 3. That's what k equals. This point right here is the square root of 3. Look at how smart we all are in here. No, you guys are smart too. You guys help figure that one out. I bombed out on this one, or on that one. I did not bomb out on this one. Okay? What is the area between the regions? All right. Ooh. Let's just look at the graph of this.
And my writing skills. Well, maybe I should have something tragic happen to me every week. I think she gave me a pity grid.
Take it.
Because it makes me feel even
But
worse.
you didn't.
Yeah.
Because I had time more than
I know, but I'm just saying,
energy
like, it's
to.
not like you asked her to do that and then.
So you have a graph that's going to look somewhat like this.
Okay.
Okay? So you need to find the area in between the two curves from 1 to 4. They happen to come together at 1 and 4. They did this for a reason. Okay? So when you find the area in between two things, you take, and like if you wanted to find the difference between 6 and 2, what would you do? Subtract. You take 2 minus 6 or 6 minus 2? 6 minus 2. So you take the bigger, the above one, the higher one, minus the lower one. Okay. So this would be the integral from 1 to 4 of 3x minus 5 minus x squared minus 4x plus 1 dx. Holy cow. All right. So this becomes negative x squared. 3x minus negative 4x is plus 7x. Negative 5 minus 1 is negative 6 dx.
So then the integral is negative 1/3 x cubed plus 7 over 2x squared minus 6x. From 1 to 4.
Okay, so if we stick a 4 in here, 4 cubed is 63, so it's negative, or 64, so it's negative 64 over 3 plus 16 times 7 divided by 2. Well, it's 7 halves of 16. Let's just put it like that for now. Minus 24 minus negative 1/3 plus 7 halves minus 6. 2, and that is 8. That's 56. 56 minus 24 is 32, right? So it's negative 64 thirds plus 96 thirds, because that's what 32 is, minus, okay, negative 1/3 and 7 halves is negative 2/6 and 21/6, which is 19/6 plus 36 or minus 36/6. 19 minus 36 is negative 17/6, and minus a negative 17/6 is plus a positive. So negative 64 plus 96 is 32 thirds, which is the same as 64/6 plus 17/6 is 81/6. Didn't get the right answer, did I? Oh, but this is all divisible by 3, so 27 halves. There we go.
I guess see.
So we did that by paper and pencil. Boy, wouldn't there be nice if there was an easier way of doing that. So what did we do on the calculator? Well, we graph them both on the calculator. You graph them. You could use the integral button and type that all in, yes. Or you can graph them. So let's look at the two graphs. We have x squared minus 4x plus 1.
This isn't quite very riveting.
I'm sorry that this isn't riveting. This is pretty cool stuff.
No, I would actually rather listen and do calculus than write any more papers.
Even the free response?
Even the free response.
Is that
Because
what it is?
Because we do best on those.
no, I don't.
I don't.
Apparently.
Yeah, me neither.
I don't know.
She's a, because that's what she always tells us. She's like, you guys are very strong free response writers.
But we all get to listen now.
Okay, so if we graph these, they look like this, kind of my drawing I had right here. Okay? So we have to take the top curve minus the bottom curve. If we look at y equals, the top curve would be the y2, the bottom curve would be y1. So on your graphing calculator, what you do is you go over the top of the equal signs and you turn these off. You turn your graphs off by pressing on top of the equal signs. That turns the graph off. And then I'm going to turn on my y2 minus y1. And you're saying, well, how'd you get y2 minus y1? Well, if you go vars, y vars, function, you can go to y2 and then go minus y1. It's under vars, and then arrow over to vars is next to clear, and arrow over to y vars, and under function, you have y1, y2, y3, y4, y5, y6. And then if you graph that, we get this parabola of negative x squared plus 7x minus 6. Just graphs there. And if we go second trace 7, find the area on the curve from 1 to 4, shades it in, and it's 13.5, which is 27.5. Okay? So there's various ways to do it on your calculator. I mean, you can write it out and have the calculator integrate it from there. You can graph it and have the calculator take care of it. Now on this one, I would definitely graph it and figure it out on the calculator. Okay? So I would take, let's slide over, y equals, and then I'm going to clear out this and clear out this. So we're going to go sine of x here and cosine of x here. I'm going to turn off y2 minus y1 for right now and graph those two. And so I'm going to graph them. Ooh, I'm not in a very good, I can't see much, can I?
I mean, you can see a little bit.
It just doesn't look like sine and cosine, does it? So I'm going to go zoom 7. 7's my trig window. And now it looks like sine and cosine curves. So I'm going from pi over 4 to 5 pi over 4. Where is pi over 4, you might ask? Well, let's trace to find the value of pi over 4. And that's right there. Okay. And let's trace to the value 5 pi over 4. So I am way zoomed out on this. So let me zoom in a whole lot. Let's go to my window. Whoa! I didn't know it would zoom that far out. So let's go like 3. How about 35 point? How about negative 35.25 to positive 35.25? And then graph that, so I'm a whole lot more zoomed in. Something doesn't seem right here. Sine of x, cosine of x. All right. So now, what's my top graph? My sine of x or cosine of x? You know what? You know what my problem is?
What?
I'm in degree mode. I need to be in radian mode. Now let's go zoom 7 and let it graph. There we go. Now if I find pi over 4, second trace, second, or no, just regular trace. trace to the value of pi over 4. It's right where they intersect. And 5 pi over 4 will be where they intersect over here. Okay? So what's my top curve, sine or cosine? Sine would be my top curve. Okay? So I want to take sine minus cosine. So on my y equals, I'm going to shut these both off. And since sine is going to be above cosine, on this one, I'm going to go y1, vars, y vars, function y1 minus vars, y vars, y2. And I'm going to graph that one. And that's sine minus cosine curve. And if I go second trace 7 from pi over 4 to second, I need 5 in front of it. So it's 5 pi over 4. Enter. It'll shade it in and give me 2.82. Which one of these is 2.82? I think it's probably the square root of 2 over 2. I think you're probably right. The square root of 2 over 2 is not right. I think it's 2 times the square root of 2. Because 2.8, because the square root of 2 was 1.4. So 2 times the square root of 2. Okay? So that's the basics of what we're doing. That's why I only gave you 2 instead of 3 things to do today. So,
Take the derivative of the assignment. We only have the videos, but the
what? Take the derivative of the assignment?
Yes, we only have the videos, not the problems.
No. Sure. Okay, there you go. So get to work on that, and then we'll do on Thursday the area between two curves without giving you the endpoints, which will be